Again. Right, okay, so we've got our topic area, our first two topics, which if you take it from the lesson one, we have scalar quantity, vector quantity, and then it looks at contact and non-contact. If you're doing it from a revision guide, page 203, we have contact and non-contact. Force is a vector quantity, so vectors, scalars, contact and non-contact. So we're going to try and effectively summarize that information into a very simple format. So first thing is, what is a scalar? Okay, a scalar, again, I'm doing this relatively quickly. When you're doing it, it should look a bit neater because you're doing it in a bit more time. So what is a scalar? A scalar has magnitude, which means size only. Okay, think of some examples of scalars. Again, use your information. You could have something like volume. Volume, okay, you can take the volume of a water in a beaker, say 100 milliliters of water. It's just got a size, it's just got 100 milliliters. So volume is a scalar, it's only got a size. Speed, how fast something is going, okay? Do pictures, help you remember. So let's do something like a little car flying along, going that way. Okay, so little car flying along, there you go, nice little wheel. Speed, so that could be going at 50 meters per second. What is a vector? Again, be consistent with the colors and the different things of what you're doing. If you don't have individual colors, for pen colors will do absolutely fine, different pencil, different shading, just something to sort of make it a bit more visual. So vector, again, look up what actually is a vector. A vector is a quantity that has magnitude, which we know is size, and direction. Okay, so highlight the fact it's got direction. Again, think of some examples. Velocity, the vector equivalent of speed. Okay, so velocity is speed in a straight line. So use an arrow. Force is a vector. So you could do a force to do something like, there's a filing cabinet, opening a drawer on a filing cabinet. You pull out with a force of 2 newtons, something like that. Okay, some more people need to come in. Okay, so the idea is just to make it as visual as possible like that. And that's essentially what a scalar and a vector is. It has magnitude, only a vector has magnitude and direction. Contact and non-contact forces. What is a contact force? So contact. So there is a physical touching of the object. You have to push the drawer. So opening a drawer, you have to physically touch the drawer and open the drawer. So contact force could be something like kicking a football. So objects physically touching. Give some examples. Again, make it colorful. Draw a diagram. So kicking a football is an example. So there's my boot. A bit of a strange looking boot, actually, thinking about it, I meant to go that way. Okay, football gets kicked, goes in that direction. That's a foot, in case you're wondering. Right, something else, give another example. So look up through your information. The examples are, you've got friction. You have air resistance. Okay, you could do something like a parachute as your idea to remember. So make it again visual. So a bit of dual coding in here, which we can look at later on. So what does that diagram mean to you? Whatever it is, this is individual to you. The whole point is yours should not look anything like somebody else's. So that's my first version, which for me is a bit more wordy. Okay, this one is a bit more pictorial. Do something that makes sense to you. And to you only. Tension is the next one. What is tension? Is a pulling force. So you could do like a little tug of war going on. Again, something again which is relevant to you. You've got normal contact force. What a normal contact force is, normal is something at right angles. So basically the force of you sitting down, gravity is pulling you down in your seat. The contact force, the resultant force against you from the chair is the normal contact force. So the force when any objects come into contact, normal meaning at right angles. What is a non-contact force? Again, consistent colors, and I try to be a bit more neater than I'm doing it here. So non-contact force is when the objects are physically separated. Okay, and again, you can give an example. What are the three non-contact examples? We've got magnets. We know from school, you've got your magnets, which have the red end and the blue end, red being north, blue end being south. So if I had two magnets, north pole against the south pole, there is an attraction between those. So those will be attracted to each other. So you got magnetic force. Okay, you've also got gravitational force, or gravity, if you want for short. And again, you can do a picture of something falling down. And then you've got electrostatic forces, forces between electric charges. And again, this can all be just done by pictures. You could just do something like positive and negative charge like that, and a force of attraction between you. You don't even need to write anything. Gravity, you could have an apple, that's a tree, by the way, and this is an apple falling out of the tree. Okay, whatever it actually looks like for you, whatever makes sense for you. Okay, that's done very roughly just to give you the idea of how to actually build it up, do it a little bit more neatly so you look a little bit more like that in reality. Right, that's basically how you build it up and make it. So that is the information, for example, that is on page 203. Now what this is doing is making you, one, read the information, which is all you do currently, and then do nothing. But this is making you do something with it. So the fact that then you're transferring that information, look at the amount of information that's on there in a format, in colorful format and picture, compared to the amount of writing that's on this page. Everything on that is the key, is summarized. So everything on this is summarized in here, okay? And when we finish, we'll end up with, for the entirety of the forces section, each of these sections will have some information, and that will be the whole topic on one single sheet of A3 paper. What the next thing we do, so that's fine building it up, okay, that makes you think about it, the whole point is this has to be minimal information. The fact of doing it like this means you have to think about it, how can I condense that information down? That begins to put it into your brain. The next step is, right, okay, how am I going to use this as a revision tool? Blank sheet of paper, either on top like this or something like that. Think, right, okay, we started off with forces. What was the first topic we looked at? Okay, what about forces? We have scalars, we have vectors. What can I remember about scalars and vectors? A vector has magnitude, well, can't remember the other things. Scalar has magnitude, has like a volume. Can't remember vector, we had velocity. Well, what does that help us with? Speed, speed in a straight line, that's velocity. And you build it up, you compare to your original. Actually, yeah, hold on, that's what there's this magnitude and direction. Okay, so you can put it in and so on and build it back up. See if you can reproduce from the blank sheet of paper, can you reproduce your original, okay? Also, what you can do once you have these in place, you can use them as a dual coding. So basically you can give somebody your picture this, you've all got access to technology like this in your phones and share a call. You can have your diagrams there. They'll help you with this, right? Okay, tell me about contact and non-contact forces. You might have just done the picture version of this, so you could do a version of this with just the pictures. So your parachutist, what does that tell you? Okay, and parachute, oh, that's about non-contact forces. Force of gravity is non-contact force because there's basically, well, actually this one's air resistance. Sorry, you got the air resistance going against the parachute and helps you to remember and recall like that. So the three things you're doing. One, there's the construction, it's a different version. One, there's the construction of the mind map, which basically forces you to think about the information in the book and condense it down into a very small format. Make it visual, so it's basically going to remind you. This has to have impact because it has to imprint in your memory. Second thing is then cover that up. See if you can reproduce it. So now you're practicing your recall, so that's putting it back into long-term memory. You're checking what you've got right, what you got wrong, adding onto it, repeat it, do the same thing again. If you got made mistakes, see if you can reproduce it again. And you're using it as a visual tool with somebody else, right? So with a partner, right, you're going to tell me about contact and non-contact forces. You've got that in front of you. They have to tell you what's on the sheet, what they've written down, okay? And then you can check against what they've actually done. And again, you can prompt each other with a diagram. So you could do, right, for contact forces, I can't remember anything. Well, this is the diagram you drew of a filing cabinet. What's that telling me? Okay, and that, oh, that's a pull force and so on. Okay, so that is the idea of how to use a mind map. And then what you'll end up with is the entire thing will have all the forces on just one sheet. So at a glance, you will have everything there in front of it. If we split forces into two parts, you will have 8 sheets, which will have all of the physics material for you to remember, rather than having a book which is that thick to actually try and do. Okay,